Okay, so we're going to let AX be the bisector of angle A for the given triangle ABC. So here's the triangle ABC. We want to prove that BX, so that length is denoted by U, over XC, which the length of that is denoted by V, is equal to AB, which the length of that is denoted by C, over AC, which the length of that is denoted by B. So let's go ahead and start the proof. So first we know that AX bisects angle A. So this implies that BAX, so angle BAX, right, is congruent to angle CAX, right? So we can let, we'll let the measure of angle BAX equal to alpha, which is equal to the measure of angle CAX. So I'll let this be alpha and this be alpha. So what I'm going to do next is I'm going to draw some extensions. Okay, so where it's right angles here. And I'll just label this D, and I'll label this E, and I'll label this distance here, oh, let's say S, just some length S, and this is some length T. Okay, so, and of course, this is, I'll just label this H and H, because of course we have this rectangle here that we've created now, right? And of course, this length is the same as this length. So, what I've done is now I know that BA is a transversal for this line and this line, DE and BC, which are parallel to each other, right? Okay, so since BA is a transversal, we know, so so this and this are congruent by the alternate interior angle theorem. So by AIA, BAD, so angle BAD is congruent to angle, so BAD is congruent to angle ABX, right? Okay, and we'll go ahead and go over here. This guy is congruent to this guy by AIA as well. So angle EAC is congruent to angle ACX. Okay, so now let's go ahead and let this be, let's have this measure be beta or whatever. So we know this is beta. And we'll let this guy be, oh, I don't know, let's say y and y. Okay, just a variable we haven't used. So we can go ahead and do that here. So let the measure of angle BAD equal beta, which equals the measure of angle ABX, and the measure of angle EAC equal to y, which is equal to the measure of angle ACX. Okay, so now what I'm going to do is I'm going to try to find cosine of beta with this right triangle and cosine of y with this right triangle. So let me first do cosine of beta. So let me go ahead and move it down. Cosine of beta is equal to, so cosine of beta is going to be S over C. So we'll have S over C. And then if we solve for S, this means that S is equal to C cosine of beta. We're going to do the same thing with cosine of y. So cosine of y is equal to, so cosine of y is equal to t over b. So t over b. And then if we solve for t, this implies that t is equal to b cosine of y. Now, I'm going to use the Pythagorean theorem. I know s squared plus h squared is equal to c squared, and I know t squared plus h squared is equal to b squared, right? Because these are the legs of the right triangle, and that's the hypotenuse. Same over here. So, by the Pythagorean theorem, I know that s squared, right? S squared plus h squared is equal to c squared. All right, well, I solved for s. This implies that, so this is the same thing as c squared cosine squared beta plus h squared is equal to c squared. And then solving for h, we get h squared is equal to c squared minus c squared cosine squared beta. What I can do next is I can factor out the c, so this will be h squared is equal to c squared times 1 minus cosine squared beta. And then 1 minus cosine squared beta, remember, Pythagorean identity, right, states that sine squared of any angle plus cosine squared of any angle is equal to 1. So if I subtract cosine squared on both sides, I get sine squared theta is equal to 1 minus cosine squared theta. So using the Pythagorean identity, right here, let me box this. So using that identity, I know that h squared is equal to c squared times sine squared beta. Now, I can do a similar argument to for this triangle here. I know that t squared plus h squared is equal to b squared. So, by Pythagorean theorem again, I know t squared plus h squared is equal to b squared. I know that t is b cosine y, so this implies that, of course, b squared cosine squared y plus h squared is equal to b squared. Of course, I can do the same argument. This implies that h squared is equal to b squared minus b squared cosine squared y. Let me put a parenthesis around that. And then, of course, this implies that h squared is equal to b squared times 1 minus cosine squared y. And then that's just h squared is equal to b squared sine squared y. So look at what I have. I have h squared is equal to c squared sine squared beta, and h squared is equal to b squared sine squared y. So, of course, this implies that c squared sine squared beta is equal to b squared sine squared y. And you'll see why I have this and why this is important. Because look, c is AB, right? And B is AC. So I essentially have that c squared over b squared is equal to sine squared y over sine squared beta. And notice c is the same thing as AB, and b is the same thing as AC. So we have part of this. So we just have to prove somehow that sine squared y over sine squared beta is in fact bx over xc. What I can do here is I can actually use the law of sines. So the law of sines states that sine of beta over x, so sine of beta over x is equal to, so sine of beta over x is equal to sine of alpha over u, right? Sine of alpha over u. Does that make sense? Remember, sine of beta over x is equal to sine of alpha over u. That's how the law of sines works for triangle ABX. Now for triangle ACX, I know that sine of y over x, so sine of y over x is equal to sine of alpha over v. Sine of alpha over v. So I want to solve for sine of beta, right? So I can figure out what sine of beta is using the law of sines. So I know that sine of beta is equal to, so this is going to be x sine of alpha over u. And over here, I want to solve for sine of y. So this implies that sine of y is equal to x sine alpha over v. Now, I know, so this implies, so let me move down. So this implies that c squared over b squared is equal to, so sine squared of y is the same thing as x sine of alpha over v squared over sine of beta is x sine of alpha over u squared. And then, of course, this is going to be x squared sine of alpha over v, right? Oh, sine squared alpha, of course, over v squared, over x squared sine squared alpha over u squared, of course. And then this is the same thing as c squared over b squared is equal to, so we're going to do x squared sine squared alpha over v squared times, so remember when we divide by fractions, we keep the numerator and multiply by the reciprocal of the denominator. So it's going to be u squared over x squared sine squared alpha. So x squared sine squared alpha and x squared sine squared alpha, both of these cancel. And what you're left with is c squared over b squared is equal to u squared over v squared. And of course, if we take the square root of both sides, right, that'll give us c over b is equal to u over v, because we know these are all positive values because they represent the lengths of the sides of these triangles and these segments, right? So now I know C is the same thing as AB. So this implies that AB over, and remember B is the same thing as AC, is equal to U. U is the same thing as BX over, and V is the same thing as XC. And that's exactly what we wanted to prove. We wanted to prove that AB over AC is equal to BX over XC, right? That's exactly what we wanted to prove. So that is the proof.